Hi students, yesterday we were discussing about problems on Thales theorem. Now today we are continuing. Here in the following figure, A, B and C are the points on OP, OQ and OR respectively, such that AB is parallel to the PQ and AC is parallel to the PR. Show that BC is parallel to the QR. Here this is a given figure. According to the given, here we observe AB is parallel to the PQ. Here AB is parallel to the PQ, and the one more given result is AC is parallel to the PR. Here AC is parallel to the PR. And next, these two results based we are proving this result. BC is parallel to the QR. So here, just we observe this figure, AB and PQ, these two are parallel. These two parallel lines are related. Triangle is POQ. POQ you take here from the figure. Triangle POQ. Here POQ triangle. According to the given, AB is parallel to the PQ. Here AB is parallel to the PQ. By using Thales theorem, here OA divided by AB is equal to OB divided by BQ. This is equation number 1 because basic proportionality theorem or BPT theorem. Next, the one more given AC is parallel to the PR. Here we observe this figure, AC is parallel to the PR. Again, AC is parallel to the PR is related to the triangle is POR. Here again triangle POR, according to the result given, AC is parallel to the PR. Again, by using a basic proportionality theorem, OA divided by OP is equal to OA divided by AB and OC divided by CR. This is the second equation because BPT theorem or Thales theorem. Generally, we observing these two equations, OA divided by AP. These two equations, equation number 1 and 2, LHS terms are equal. Similarly, RHS terms are also equal. Here from 1 and 2, we have OB divided by BQ is equal to OC divided by CR. Here, this result we observe in the figure, OB divided by BQ, OC divided by CR. Now, these two ratios are related to the triangle is QOR. In this triangle, OB and OQ both are in the form of an ratio, and similarly OC and CR both are in the form of an ratio. By using Konnor's Thales theorem, Konnor's Thales theorem, BC is parallel to the QR. Hence, BC is parallel to the QR. This is the result. The next problem, the seventh one, using basic proportionality theorem, prove that a line drawn through a midpoint of one side of a triangle parallel to another side bisect the third side. Here, according to the given statement, this is a statement of midpoint theorem. That's why here, using basic proportionality theorem, we proved midpoint. We are proving midpoint theorem. Here, first, according to the given statement, we are construct the figure. Here, a line drawn through the midpoints of one side. Here, according to the given triangle, I have considered A, B, C vertices and one side of a triangle. Here, any one of the side we considered. Here I have considered AB is one side. Now, on AB, I have considered D is a midpoint. Now, this point through I have drawn the line. I have drawn the line is reach the AC on E. And according to the statement, we are constructing this figure. The next one. And one more given is that line is parallel to the another side. Parallel to another side means D is parallel to the BC. Now, first you write given points. Given, let triangle ABC DE is parallel to the BC is a given. E is point on AC. And the next one is to prove this result is also in the given statement bisect the third side. Here we consider the first side is AB, then second side is BC, then the remaining side is AC. This is the third side. This third side is bisected. Bisected means divided into two equal parts. That's why AE is equal to CE. AE is equal to CE. Or E is a midpoint of AC. Next, proof part. From the figure, here D is a midpoint of AB. It means AD is equal to BD, implies AD divided by BD is equal to 1. And again, by using the Thales theorem, DE is parallel to the BC. By using Thales theorem, DE is parallel to the BC. Now, AD by BD is equal to AE by CE. Now, we have already calculated AD by BD is equal to 1. Here you put it 1 is equal to AE by CE, implies CE is equal to AE, or AE is equal to CE. Therefore, E is midpoint of AC. The eighth question. Using Konnor's basic proportionality theorem, prove that the line joining the midpoints of any two sides of a triangle is parallel to the third side. See, according to the given statement, first we draw the figure. In this statement we observe triangle is given. First you have to draw the triangle A, B, C, and according to the given statement, any two sides. See, I have considered in this figure AB and AC. AB and AC, I have considered the two midpoints D and E, join DE. Now, ABC triangle, I have considered the sides are AB and AC, then the midpoints are D and E. D is a midpoint on AB, E is a midpoint on AC. And these two results based, we are proving this line is parallel to the BC. This is the result of the given question. That's why here first you write it all the given points given. Let triangle ABC, and one more point is D is the midpoint of AB, E is the midpoint of AC. These 2 points are given. Here AD is equal to BD because D is the midpoint of AB, and the one more result is E is also midpoint of AC. That's why you write it AE is equal to CE. These 2 points are given. These 2 points related, we are proving DE is parallel to the BC. This is a to prove point. That's why here you write to prove DE is parallel to the BC. Now construction is not necessary, but directly you have to take a result. Proof part. Proof. See, from the figure, according to the given, AD is equal to BD. Here you take AD is equal to BD. Therefore, AD by BD is equal to 1 or 1 by 1. Similarly, and one more given is AE is equal to CE. Again, therefore, AE divided by CE is equal to 1 or 1 by 1. The next point is here. This is equation number 1 and this is equation number 2. You have to consider it. Here AD by BD is equal to 1 and AE by C is equal to 1. From equation number 1 and 2, RHS terms are equal. That's why from 1 and 2 we get AD by BD is equal to AE by C. Here you observe AD by BD, AE by CE. These two are in the form of a ratio, but both are equal. It means is related to the converse basic proportionality theorem. Here directly you take by converse basic proportionality theorem. Proportionality theorem. Hence, DE is parallel to the BC. This is the result. Next one, ABCD is a trapezium in which AB is parallel to the BC. and its diagonals intersect each other at the point O. Show that OA AO divided by BO is equal to CO divided by DO. Here, according to the given, first we construct the figure. ABC is a trapezium. Now, according to the given, we constructed the figure A, B, C, D is a trapezium. According to the definition of a trapezium, a one pair of parallel lines are there in the geometrical figure is called a trapezium. Non-parallel sides are not equal. And the one more point is AB is parallel to the DC. AB is parallel to the DC. And one more point is its diagonals intersect each other at point O. Here we draw the diagonals AC and BD. Both are intersect each other at point as a O. Then according to the given we constructed the figure, and the next point is you have to prove it. AO divided by BO is equal to CO divided by DO. Here, according to the given, first you have to write all the given points, then we are proving AO by BO is equal to CO by DO. Here, given ABC is a trapezium, here you write it, let A, B, C, D is a trapezium. And AB is parallel to the DC is also given. You write it, AB is parallel to the DC, and the one more result is diagonals. The diagonals are AC and BD intersect at O. This is the given. And to prove according to the given, these are the given things. These given things we are utilized. Then we proving AO by BO is equal to CO by DO. That's why AO by BO is equal to CO by DO. And the next one, generally we observed, and the one more point is the basic knowledge, basic proportionality theorem and Konnor's basic proportionality theorem we are utilizing, and then we are proving this result. Otherwise it is not possible. That's why we are constructed here. Draw EO construction, draw EO, but E is point on AD, point on AD such that EO is parallel to the DC. Is a construction. This construction based we are proving AO by BO is equal to CO by DO. Here, proof part. Here we observing this figure, we are constructed EO is parallel to the DC and EO is also parallel to the AB because AB is parallel to the DC. It means AB is parallel to the EO, EO is parallel to the DC. It means AB is EO and DC. These three lines are parallel. And one more point, by using the basic proportionality theorem, based we are observing the triangle ADC is a triangle. EO is parallel to the DC. These two result based we are using basic proportionality theorem. Here you write it from the figure from the figure ADC triangle ADC, comma, EO is parallel to the DC, Now, by using basic proportionality theorem, AE by ED or DE is equal to AO by CO. This is the equation number 1. And again, similarly, EO is also parallel to the AB. Again, in this figure, EO is parallel to the AB. Here, this result is related to the triangle is ABD. Here, you write triangle ABD and EO is parallel to the AB. Here, because EO is parallel to the AB, parallel to the DC. Because EO is parallel to DC, DC is parallel to the AB. And again we are using basic proportionality theorem. Basic proportionality theorem, DE divided by AE, ED or DE, and DO divided by BO. This is the second equation. Now we observe AE by DE. Here is DE by AE. That's why we are taking reciprocal. We are not considered second equation. Here you take the reciprocal form. Taking reciprocal AE by DE is equal to BO by DO. This is the second equation. Here, from equation number 1 to we observe AE divided by DE is equal to AO by CO. AE by DE is equal to BO by DO. Here, these two equations, LHS terms are same. AE by DE, AE by DE. That's why from equation number 192, we have OA divided by CO is equal to BO divided by DO. But the result we observe AO by BO is equal to CO by DO. Here cross multiplied. Hence, cross multiply AO by BO is equal to CO by DO. Next one. The diagonals of a quadrilateral ABCD intersect each other at the point O such that AO by BO is equal to CO by DO. Show that ABC is a trapezium. First, we are understanding here, we are already solved the last question. This is the converse. Now here, trapezium. I have already explained the trapezium definition. The trapezium definition is in a geometrical figure or in a polygon, any one side, one pair of parallel sides are there in the geometrical figure or in a quadrilateral, that is called a trapezium. Here, one pair of opposite sides, that's why AB is parallel to the DC, or according to the given figure we are proving the result. Here, diagonals of a quadrilateral, it means the given is quadrilateral. According to the given statement, we draw the figure, we have constructed the figure. ABCD is a quadrilateral. Diagonals, then we draw the AC and BD diagonals. AC and BD are intersect point at O is given, and one more point is AO by BO is equal to CO by DO is also given. Now, according to the given, first we write all the things. The given points are given. Let A, B, C, D is a quadrilateral. Is a quadrilateral. Diagonals are AC and BD intersect at O. And the one more given is AO by BO is equal to CO by DO. Here, AO by BO is equal to CO by DO. Again, the next point is to prove. Here, ABC is a trapezium. Here you write ABCD is a trapezium, or AB is parallel to DC. Now, the next point is construction. This is very important because there is no option for this. That's why in triangle ADC or ABD there is no parallel line. That's why we are constructed again join or draw EO. Now E point is on AD. Here the construction part is draw EO is parallel to the AB. Draw EO. Point E is on AD such that EO is parallel to AB. The input part. Here we are constructed EO is parallel to the AB. EO is parallel to the AB's related triangle is ABD. Here you write from the figure. Triangle ABD, EO is parallel to the AB by basic proportionality theorem. DE divided by AE is equal to DO divided by BO. Now taking reciprocal AE by DE is equal to BO by DO. This is the first equation. And again we observe in the given AO by BO, CO by DO. Here AO by BO is equal to CO by DO because the given cross multiply AO by CO is equal to BO by DO. This is the second equation. Here we observe for equation number 1 and equation number 2, AE by DE is equal to BO by DO, and here is also AO by CO is equal to BO by DO. RHS terms are BO by DO, and here that is also BO by DO. That's why both are equal. That's why AE by DE. Then from equation 1 and 2, we get AE by DE is equal to AO by CO. Here we observe the figure AE by DE, AO by CO. Now AD is divided in the form of and ratio AE by DE, and AC is also divided in the form of and ratio AO by CO by using basic proportionality theorem. This is the result of Thales theorem, and we are using converse BPT theorem. EO is parallel to the DC. Here by converse BPT theorem, now EO is parallel to the DC. Now we are constructed EO is parallel to the AB and EO is parallel to the AB. This is the construction part. Generally we observed these two results. EO is parallel to the DC. Here is EO is parallel to the AB. It means therefore EO is parallel to the DC and also is parallel to the AB. The result is true. Now we observe in the figure AB is parallel to the DC is true. Therefore AB is parallel to the DC. Hence ABCD is a trapezium. Because the statement of definition of trapezium is true, that's why AB is parallel to the DC is a pair of opposite sides are parallel. That's why ABCD is a parallelogram. Next one, standard concept, the criteria for similarities of two triangles. Here, criteria for similarities of two triangles means, now the standard concepts are there. One is AAA similarity criterion, ASA similarity criterion, SSS similarity criterion, and SAS similarity criterion. Here, these are very important point of an examination point of view. That's why that concept based on these standard results are there. That's called a theorem. The first one is AAA similarity. Here, AAA means angle similarity criterion of two triangles. Now the statement is here, if in two triangles the corresponding angles are equal, then their corresponding sides are proportional and hence the triangles are similar. Now the last class we already discussed two triangles are similar. Here similar means corresponding sides are equal and corresponding angles are equal and corresponding sides are proportional. These two conditions are true, the given two triangles are similar, otherwise is not true. Now here in this statement based, first we draw the figure, then here if two triangles, that's why according to the given statement we are draw the two triangles A, B, C, and the next one is D, E, F is another triangle. Now, and one more statement is the corresponding angles are equal. Corresponding angles means here we observe these two triangles. Angle A is equal to angle because both are the apex angles, and here angle B is equal to angle E because both are in the left side of the triangle ABC, and this angle is left side of the triangle DEF. Similarly, and one more angle is C. This is the right side of the angle ABC, and this is also right side of the angle DEF. Now, angle A is equal to angle D is given because both are the corresponding angles. Similarly, angle B is equal to angle E, and angle C is equal to angle F. Now this is the given. Now these points based we are proving corresponding sides are proportional. Corresponding sides are proportional, then these two triangles are similar. Here, according to the given, first to write it all the given points. Here given, let triangle ABC and triangle DEF are the given two triangles, and one more statement is the corresponding angles are equal. Here angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. This is a given. Now, to prove corresponding sides are proportional, here AB is corresponds to the DE, BC corresponds to the EF, AC corresponds to the DF. Here AB divided by DE is equal to BC divided by EF is equal to AC divided by DF. Now this is the result. Now generally we observe these two figures, there is no option, that's why we are taking a construction. The construction part is here in triangle DEF we are constructed, this is a M and this is a N. Here this line is DM is equal to the AB, DN is equal to the AC. We are constructed here according to the construction. Here construction draw MN, M and N are the points on DE and DF such that DM is equal to AB and DN is also equal to the AC. This is a construction part. Next one, proof part. Here AB is equal to DN, AC is equal to DN. These two are equal. This result based we are proving AB by DE is equal to BC by EF, AC by DF. Now from the figure we have constructed the MN line. The MN line is formed the another triangle DMN. Here DMN and ABC, taking these two triangles are congruent. First we prove. Here triangle ABC and triangle DMN. Here AB is equal to DM. AB is equal to DM because construction. And the one more point is angle A is equal to angle D because a given. Angle A is equal to angle D. Here angle A is equal to angle D because a given. And the next point is AC is equal to DN. AC is equal to DN because is also construction. Here we observe these three results. This is a side related, this is angle related, and this is side related. SAS statement using SAS, side angle side, congruency or statement, you take statement using SAS statement, these two triangles are congruent. Triangle ABC is congruent to the triangle DMN. This is a congruent symbol. Now, according to the definition of a congruent, if two triangles are congruent, then the corresponding sides and corresponding angles are equal. Here, angle A is equal to angle D is already given, but the remaining two angles are there. Angle B is equal to angle M, angle C is equal to angle N is true because we already proved this result. This result based angle B is equal to angle M and angle C is equal to angle N because CPCT means corresponding part of a congruent triangles. Next one, again the BC is a base and here MN is also base. These two are equal. Now again we observing angle B is equal to angle E, angle B is equal to angle M. Now we proved these two results based. Therefore angle M is equal to angle B, this is equal to angle E, and similarly angle C is equal to angle F, angle C is equal to angle N. We already proved these three are equal. Angle C is equal to angle N is equal to angle F because corresponding angles. Here angle M is equal to angle E, angle N is equal to angle F. Now these two are corresponding angles, that's why MN is parallel to the EF. Therefore MN is parallel to the EF. Next, but the result is AB divided by DE is equal to BC divided by EF is equal to AC by DF. Now the first point is, now we proved MN is parallel to the BC. Here MN is parallel to the BC to the EF by using basic proportionality theorem. DM by DE by basic proportionality theorem. DM by DE is equal to DN by DF. Now, according to the construction, DM is equal to AB, DN is equal to AC. Here, AB by DE is equal to AC by DF because DM is equal to AB and DN is equal to AC. Here, AB by DE, AC by DF, similarly, AB by DE is equal to BC by DF. Now, here, from these two results based, therefore, AB by DE is equal to BC by EF is equal to AC by DF. Therefore, their corresponding sides are proportional. Corresponding sides are proportional. Hence, the triangle ABC is similar to the triangle DEF because according to the given, the corresponding sides are equal is given, and now we proved corresponding sides are proportional. These two conditions are true. The given two triangles ABC and DEF are they similar.